For thousands of years, sailors have been crossing oceans. And they did this by tuning in with the rhythm of the sea. No engines, no satellites, no safety net. Just wood, canvas, and balls. They knew the trades, they followed the rum lines, they watched the skies, they could tell when to go and when not to. They understood the rhythm of the ocean. And if you're serious about crossing an ocean, you need to understand that too. In this video, I'm going to explain that rhythm and how it relates to the Pacific and the Atlantic Ocean. We'll discuss the three-dimensional cells that wrap around the Earth and make the trades, how they flow, and how the trades change with the seasons. And I'm going to give you a super simple drawing to show other people how this works so even non-sailors will get it. Then we're going to plan an Atlantic crossing the hard way, from the US to Gibraltar. We're going to talk about the dangerous parts of that trip, the lows that come out of Canada and try to roll you over, and the parts where you might get stuck in the doldrums. So lastly, we're going to talk about what to do if you screw up, when you screw up. If you sail into a low or you sail into a high, what's the dangerous part? What's the easy part? How do you get out of it? And I've got a really good sea story for that section. So if you're here for the sea stories, skip to the end. If you're here to learn something, let's go ahead and get started because we got a lot to cover. Come on. All right, before we do anything, there is a first and a second video to this series, okay? So go up here, watch the 101 course first if you haven't done that, and then you'll get a better understanding of what all of the nomenclature is for this video. So, as a sailor, you need to be thinking in three dimensions. Most people, when they look at a wind map, they see a two-dimensional map. They think of the wind on the surface level because that's what's affecting them. And really, when you think about it as a sailor, you need to think about the wind as three-dimensional, right? You have the entire atmosphere, and that whole thing has wind moving up and down and around and kind of all over the place. But it does have a pattern. So all I need to teach you is how the pattern works. And it's not hard. Okay, picture it like this. The equator is very hot. Hot air rises. It spreads out way up in the atmosphere and cools and then comes back down around 30 degrees north. That tube of air around the globe is called the Hadley cell. It's actually named after a British lawyer, believe it or not, that figured this out in the early 18th century. So from 0 to 30, we've got the Hadley cell. From 30 to 60, we've got another cell, that's another tube that wraps around the Earth called the Ferrel cell. The Ferrel cell moves in the opposite direction. And the reason that the Ferrel cell moves in opposite directions than the Hadley cell is because that one's not really driven by heat in the same way, and it's not convection that drives it. It's more like a byproduct. It's caught between two very strong cells that use convection. The polar cell at the top, those polar ice caps pull all that cold air down, and it's revolving the same direction as that warm air that's pushing up on the Hadley cell. And if you just think of it like three cogs in a machine, these two are moving the same direction, and this one's in the center is moving the opposite direction. Not because it wants to, because it has to. That's the only way it'll work. This is important for us sailors because that intersection where the Hadley cell and the Ferrel cell meet, that's what you're going to ride to make it across the Atlantic. That's what creates our mid-latitude westerlies. And then when you take into account that vertical motion and the Earth's spin, you've probably heard of the Coriolis effect. The Coriolis effect bends those winds westward in the tropics and eastward in the higher latitudes. And that's what gives us the northwest trades and the westerlies. The absolute easiest way to explain this is to take a map of the North Atlantic. Draw one circle from the equator to 40 degrees and another circle from 40 to 60 degrees. The big one flows like a clock, the other one the other direction, like it's two gears in a machine, a big planet-sized wind machine. Now, if you're asking yourself, didn't this idiot just tell me that the Hadley cell went from 0 to 30 degrees and now he's trying to have me draw circles at 40 degrees? Yes, and good catch. As sailors, we're not really interested in where the air is sinking. We're interested in where it actually makes the wind change direction and give us that westerly, which usually happens right around 40 degrees, like 35 to 40 degrees, depending on the season. Have you ever heard a sailor reference the horse latitudes? This is kind of a weird no wind zone where the Hadley cell air is sinking right around 30 degrees. And the roaring 40s is where the Ferrel cell now takes over, and that's where the wind changes. Okay, so the takeaway here is we're not just blindly trying to follow wind patterns. There's actually a big conveyor belt that we're going to get on and surf all the way across the Atlantic. And understanding how that works is key to doing that without getting your ass kicked. There are a couple things to watch out for. So your job is to jump on this conveyor belt and ride it across the Atlantic. But to make your job a little more interesting, that conveyor belt is constantly changing position, changing latitude. It's not in the same spot all the time. Also, there's these big low pressure storms that come out of Canada. Have you ever seen Perfect Storm? That was a Canadian low. They're trying to run you over and ruin your day. And just to make this interesting, there's something called the Azores High that can be 700 miles of doldrums. Everybody knows what the doldrums are. That's no wind at all. And there's not a lot of sailboats that have that kind of range. So you got to be careful you don't dip too far down. And oh yeah, that's moving constantly all over the place as well. So basically, the farther you go north, the more steady that conveyor belt is, but the higher chance that you're going to get run over by this 50-knot behemoth of a storm with big waves and damage the boat. But you go too far south and you're stuck in that high, and now you're motoring. And if you've talked to anybody that's ever crossed the Atlantic, this is threading the needle. They've probably gotten caught in both, actually. The sweet spot is right between 40 degrees, like 38 degrees north to 43 degrees north. That's kind of where people go to ride that wave. So just to show you on another ocean that this is pretty much the same thing mirrored, New Zealanders and Southern Ocean sailors have been using this forever. It's called the elevator. You go down to 40 degrees, you ride the elevator as far as you want until you want to get off, and then you get off in American Samoa or Tahiti or Easter Island, or you ride it all the way to Chile. And that's how you cross the Pacific Ocean from New Zealand, the wrong way. Okay, now we're going to talk about those obstacles a little deeper. The first one being the Azores High. You need to know how to identify it, what its characteristics are, so you can route around it. The Azores High is a massive, slow-moving, high-pressure system that usually parks itself in the North Atlantic somewhere around 30 degrees north, right where you're trying to go. You don't sail through it, you sail around it. So this high forms as part of the Hadley cell. The hot air rises at the equator, drifts north, cools down, and then comes down somewhere around 30 degrees. And that air coming down pushes on the atmosphere, and it makes a high pressure system, which you'd think would make a lot of wind, but actually high pressure makes no wind. Low pressure makes a lot of wind. And inside that high pressure area that's constantly moving all over the place, you have miles and miles and days worth of doldrums, just no wind, nothing. And this is why those horse latitudes are called horse latitudes, because sailors actually had to throw their horses overboard because they didn't have enough water to keep them alive during this time while they were waiting for wind. So in order to spot it, you have to know where to look. In the summer, the high drifts north, sometimes as far as 35 or 40 degrees north. In the winter, it sags south towards 25 degrees. It shifts east to west as well, usually centering somewhere around the Azores or Bermuda. So sometimes you can hear it referred to as the Bermuda High as well. It's always moving and almost always in the way in some form or another. So when you're looking at a wind map or pressure chart, what you're looking for is a big round area of clockwise wind circulation. That's the key, clockwise. In the very center, no wind. And then you'll often see isobars that are wide and spaced out. There's a lot of room in between where there's no wind and where there's wind. It literally looks like a clear blue donut of sadness drifting its way around the Atlantic. It's a really good description. Don't try to punch through this. You'll burn hundreds of gallons of fuel. It's hot, it's slow, it's miserable. Sail around this thing. You might not even have enough range to make it to the other side, and if you run out of fuel, then you're really screwed. There is no guarantee that the wind will return when you think it's going to. There's stories of sailors being caught out in these things for weeks and almost dying of dehydration. And worst of all, once you're in it, there's no way to get out of it. There's not even enough wind to make apparent wind, for even a light catamaran or something to sail out of this. So you're going to be stuck in the doldrums bobbing, which, I've been in the doldrums in the horse latitudes before, and sometimes it's one of the best times of the passage because you can just not stand watch and have some fun and play some board games. And I've had a lot of good times in the horse latitudes, but we also have an engine and an EPIRB and a lot of water and a water maker. So you can imagine how scary these were for sailors back in the day. So the sneaky part of these things isn't just the center, it's the edges as well. They can look breezy on a grid or on PredictWind, but in actuality, once you get in there, it's not enough to sail. It's like 7 knots of wind. It's just not enough to push the boat. You're going to be bobbing around doing 2.4 knots, swearing at your sails, and your crew is going to be eyeing the throttle, and that fuel gauge is going to be eyeing you. Okay, now let's talk about the real danger. Most serious Atlantic storms are born right here, right over the Great Lakes in eastern Canada. They start inland, they pick up energy as they hit the Gulf Stream, and then boom. They spin up into full-blown lows, and they start charging east like they've got dinner reservations in Lisbon. A good thing to get accustomed to is trying to find and look at this information from a land-based site so you can see this happening live. I use tropicaltidbits.com. If you click over here on models, go to GFS and select North America as your region, then hit the MSLP layer, you'll literally watch these systems form over land, and you can see them happening, and then you can see them going out to sea and then gaining strength. And then you can switch to PredictWind, and you can see that happening from the water side as well. So you can switch back and forth and kind of keep an eye on what's going on out there. And if you see something crazy that you don't see on PredictWind, it's time to adjust your course or find a place to hide, or just keep an eye on it and watch it, really. And usually what happens is these things do the same thing we're trying to do. They hit that conveyor belt and they just scoot right across the Atlantic, and they're powerful. So you gotta be careful. So I actually got ran over by one of these storms just last December, taking my boat, my personal boat, down from the Chesapeake to Cartagena. And this thing was not forecasted when we left, but about day 4, we were probably 600 miles out. It slammed into us. And luckily, I could see it coming, and I prepared everything. I routed all the lines inside the shrouds, and I basically hove to the boat for 5 hours before the storm hit. And it hit us so hard that one of the solar panels ripped out of the arch. All the bolts were still on the arch. It ripped the extrusion right through the bolts. That's power, man. Crazy. I heard afterwards that another boat was actually rescued that night. Like they called the Coast Guard and got off the boat because they were rocked too. It happens, You got to get a good boat, something good. I still have a hole in where that solar panel is. I can't find the damn thing here. All right, the third thing that we're going to talk about is the swell. So you can have a perfect wind passage, but it's still horrible because of the swell. It doesn't line up together, and there's a storm up here and there's a storm down here, and the secondary swell is directly opposite from the primary swell, and everybody's sick, and they're doubling up every once in a while and just getting your boat totally wet, and you're basically a submarine for 10 seconds, and everything's leaking because all plastic boats leak, and it's just miserable. Okay, so we're here at PredictWind. This is the opening screen. We're on the wind map. We're on the GFS. Well, since we're close to the States, we're going to use GFS for this one. And we're going to see what it's going to be like if we leave today to go on a passage to Bermuda. Here's the States here. Here's Bermuda. We're going to do weather routing, sail routing. There we go. And we're going to go from the Chesapeake. We're going to go down to Bermuda. This is St. George's Bay right there. That's the The anchorage in Bermuda, if you guys have ever been there, it's cool. Boom. We're going to start it up. Okay, so here's our wind model. This isn't really about wind, so we're going to talk about the swell. So we're going to go to the tables, and we're going to go down. There's wind, direction, angle, rain, cape, temperature, pressure, and there we go, is wave height. So right here is what we're interested in, is combined wind wave and swell. What we want to see is we want to compare the wind wave, the primary swell, the secondary, and the tertiary swell to see what's going to happen in the next few days, okay? So we're going to go to primary swell. We're going to see what direction that's coming from when it's big. On the 9th, it gets the biggest. On the 9th, it's from 110, 115, and all of the models agree it's between 115 and 125. And then the secondary swell is on the 9th from, looks like 180. It doesn't say. This is weird. This is a strange one to read. We have some incongruous results. But basically what you want to do is you want to make sure that the primary and the secondary swell are not going to be coming from 180 degrees out. So like for instance here, we've got 115 and the secondary swell is from 125. Okay? Hugely important, and that's where you find it. You got to use the map, either do a weather route or a departure planning, and then go into the tables, and then you can find the actual wind, primary, secondary, and tertiary swell. The program is not made to map all those out for you. You have to dig for it. And that's where to find it. All right, let's talk about how we actually use the AI and all of the program to route ourselves across the Atlantic. We're not going to go the whole way across. It's just going to make the video way too long. I'm just going to show you 2 legs of it, and we're going to pretend like we're leaving now from Chesapeake to Bermuda, and then from Bermuda to Azores, okay? Because it's 2 different legs, but this is the biggest legs. Okay, so what we're going to do when we first start out is we're going to look macro level, okay? We're going to look at the entire ocean. We're going to look as far out as we can get, which is about here. And we're going to just scroll through in the next 7 days, because that's how long we're going to be out to sea. And we're going to see what's happening macro level, if anything crazy is happening. I'm not seeing anything crazy around our blue dot and our green dot. Nothing nuts is happening. This is kind of all normal movement, which should be, because these are some of the best months to do this crossing. We're in May right now. Now we're going to zoom in a little bit just to the North Atlantic. So here's the States, here's Europe, here's Gibraltar right here. This is a big picture of the Atlantic. Now you tell me, where is the Azores High? Is it here? Is it here? Or is it here? Number 1, number 2, or number 3? Stop the video, comment below, let me know which one it is. So if you said number 1, you would be wrong. What did I say in the beginning of this video? The highs move in a clockwise format. The lows move in an anti-clockwise format. And this is not moving in any format. It's just kind of all over the place. So this is the high right here. It's right where we need to go on our next leg, which is why I want to do both of these legs. So there's the high, and look how it moves. It's coming up, it's kind of floating around, it's that donut of sadness, and it's moving up and down and kind of all around, and then later on gets a little closer to the Azores. Okay, that's all just in a week. All right, that's big picture. Now let's go down to our actual route, and we're going to use the AI weather planning to plan our route with the weather router first. So we're going to go sail route, calculate route, and if you don't know, this program, you can set your polars for your boat. Polars being the characteristics of every boat. This is a boat polar map right here. This says at this wind angle, the boat will sail at this speed. It has this waterline length, and they have in PredictWind polars for a lot of boats. There's swans and X-boats and oysters and Jeanneaus and J-boats, Halbergrassis. There's a bunch of different boats, Allure. You can pick one that's close to yours. Like they don't have an Oyster 485, but they have an Oyster 46. So that's probably pretty close to what my boat is going to do. So we're going to do that. And then just letting you know, I don't have time to go into this really in depth, but just letting you know while this is loading, this is how polars work on boats. So that's what the AI is using for this. So it's taking all 6 models, and it's showing you, okay, cool. So this is what's going to happen. So, you know, it's really cool to have this user interface that's super, super slick and sexy. But what we're more interested in is the tables. So we're going to go to the tables and we're going to see if there's any wind, if there's any cape, if there's any waves that are super big. It looks like to me, like all of the models agree, the wind is going to be between 5 and 15 knots. That's catamaran territory, people. I mean, if you don't have 10 knots or over on a big monohull, you're going to be motoring. So this may be a time where this is not a good spot for you to leave. It depends on your boat. If you have a big steel boat, it might not be good. There's the wind direction. It's kind of, it's not really all over the place. It looks like it's matching mostly. The direction is matching. The rain is, you know, we'll get some rain and we won't get some rain. The Cape, we need to watch out for Cape up here at 1200 on the 7th of May as we're coming out of the Chesapeake. There's a very good chance that we're going to get hit by a storm, or at least a few squalls. This is the measurement of the energy of the ocean. You can look all this stuff up, please do, and dive deep into it. This is just a cursory examination to show you, or else this video would be an hour and a half long. Temperature, pressure, there's the wave height that we talked about, the combined wind, wave, and swell, which is a very easy representation, but you should always check all of them to make sure that they're not juxtaposed to one another. We're going to leave it on combined just for this because we already talked about the wave height and direction and period. There's the speed. There's roll, vertical access, and slamming. So slamming incidents is going to be a problem at the end of this trip because we're going to be going, looks like we're going to be going upwind. We can go back to the map and see what's happening here. But yep, we're going right upwind right at the end of the trip, and we're going to be slamming against it right there. Okay? So that's a problem. So maybe this time isn't really the best time. So now we're going to say departure planning, and now we can space that out by 24 hours, just like I did on the last video. We're going to space that out by 24 hours, and we're going to see if maybe one of these is better than the others. All right, we got our map here. We've got a lot of alarms. It looks like we've got vertical acceleration and lightning. So that's what we saw on the last screen on the last tables where there was some thunderstorms here. So this is where we're going to hit the storms. That's going to be right before we get into the Gulf Stream, so maybe that's not a good idea. Let's see which one has the most storms. So this one, if we leave today, we're going to get hit by a thunderstorm right as we're entering into the Gulf Stream. That's probably not going to be a good idea. Okay, we got to take a break super quick. I totally spaced. I need to teach you guys how to find the currents. PredictWind has really good currents in this program, but they're micro level. They're only 8 kilometers. So if you want to see where the entire Gulf Stream is, I use earth.nullschool.net. That's up here. And this is a really cool program. I got to move it up so I can see the bottom. So you click on this, and you click on currents. And now this is an animated current design. So we're leaving from the Chesapeake. And once this propagates, you can see exactly where the currents are. Okay, so if you want to see how far off the shore the Gulf Stream is, you can see it right here. It's right here, right on 3515 and 7538, and then it goes over here from 3459 to 7479. And if you change this to knots, if you go in the center of it, it's 3.1 knots. So that's significant. That's significant enough where it's going to ruin your day if it's wind versus current. Very, very dangerous. Be very careful if you see wind from the north, like if a big low's coming through and it's going to blow from the north, and then you have that southerly current. When you're talking about current and wind, you always talk from the direction it's coming from. So northerly wind, southerly current, it makes these square waves that are super dangerous. I met a couple that died out here. It's a long story, but just be very, very careful with this area while you're crossing this. And if you need to, you can draw, take down these coordinates one by one and just put waypoints into your chart plotter, and you can actually plot out where you're going to cross the Gulf Stream and where it's going to be and where it's going to be the worst. Okay? So earth.nullschool. You can also see wind here, which is nice. It's free. And you can see waves. All right, so it's a good map to bounce against. The cool part about earth.nullschool.net is you can go from surface all the way up to high winds. These winds are traveling at 60 knots way up in the atmosphere. Okay, so if you're into meteorology, this is a good resource. Let's go back to the video. Let's try tomorrow. Looks like tomorrow's good. The next day. All right, looks like we're going to get some higher winds on the fourth day, and they're going to carry us right there. Actually, that fourth day might be the day. So let's see. We've got time upwind 31% if we leave today, 16% if we leave on the 9th. Time downwind 14 and 31. Actually, it's a lot better on the last day. It's getting better and better. So we've got to deal with 5% at 20 to 30 knots, but 75% of the time we're going to be 8 to 20 knots. So you're going to be able to sail more if you wait until the 9th. And that's really what you're looking at is, like, how is this going to be for a sail? Should I wait a couple days? Yeah, absolutely here. Time upwind is 2%. Time upwind is 11%. Time in 1 meter waves. This is going to tell you how bad the waves are going to be. Looks like the waves are going to be worst on the 3rd day and best on the 1st day. So, you're going to be motoring more, but maybe the wave state will be lower. So that's something you got to wear and weigh out. And then this will tell you what you're doing for roll and vertical acceleration and all that stuff. So, lastly, we're going to look and look at the graphical representation of waves. We can do wind. We can do wave. Here's the waves. So it looks like as we're coming out here, we've got a lot of waves action going on right in front of the Chesapeake in the Gulf Stream. And then again, that pops up on the 9th. So it looks like we're going to get some wave action if we leave then. And not too bad all the way to Bermuda. Okay? Okay, so now we're going to do this one more time. We're going to do it from Bermuda to Azores. That's a lot longer passage. That'll be an 11-day passage. And we can see, some of what the open ocean and that Azores High will do to our track. Let's go. Okay, since we've already done this, we're going to go Bermuda to Horta. Here we go. Bermuda, that's close enough. And that's actually Pico. There we go, Horta. And we're going to go route. So I'm not going to go through the whole macro, micro, looking at everything again because this is the same exact forecast. But you should do this every day, twice a day. What else are you doing out there? Okay, I really like this forecast because everything's in agreement all the way up to here. So it looks like the first part of this passage is going to be very nice. If all of them are in agreement, this is very good for us. And then only one diverges and the rest of them are in agreement the entire rest of the way. That makes me happy, and that's what I want to see, okay? Now we're going to go into the departure planning and we're going to see what happens there. A lot of the times when you're in port, the only thing that you're really using is departure planning. The sail planning is for when you're going, and that's the one you're updating every other day. But the departure planning, you use departure planning too underway just to see what'll happen, but that's kind of a moot point because you're moving. So now this is what we really want to see. And the graphical representation is great. It's pretty and everything, but what we want to see is those tables. So we're going to switch to tables, and we're going to go right here. Time upwind, almost all the same. Time reaching and time downwind, not a very big difference. Time in less than 8 knots, 0%, 4%, 5%, 13%. That means that basically, if you leave right now from Bermuda, you might not have to motor the entire time. If you wait 4 days, you're going to have to motor 15% of the journey, which is, a good day and a half. That's a lot of motoring. Let's see what's happening with the waves. Time in ridiculously big waves. If you leave now, you're going to spend a significant amount of time in 5-meter plus waves. And then that goes down every day. So that's what's going to happen. You're going to have to motor a little more, but you won't be in this ridiculous wave state. And you can see that on the map. If we go back to the forecast and we do maps, and then we do wave map, and right there, boom, that's where we get hit by these big waves. Yep. Let's zoom out just a bit so we can see it. Right there. Yeah. That's some bigger waves right there. At a certain point, you're not going to be able to trust this forecast 10, 11 days out. So you just have to make your best guess and kind of go with it and, let the chips fall where they may at a certain point. Well, look, I know this is kind of flying through the actual planning part of going offshore, but the way I wanted to present this video, this is the easy part. This is the AI telling you. You just have to be able to know where to get this information and then pick whatever you want out of it. Just know that you can get a lot more information than just wind. And you need to start comparing all those datas. The point of this video was to teach you the big picture and how everything works together. So, if you lose your laptop or you get hit by lightning or something, you know how this is going to work. Okay, rules of thumb on the Atlantic crossing from west to east. Don't leave when there's a low forming if you're in Bermuda. The Bermuda's an 11-day crossing, 12 days, 13 days, sometimes 2 weeks. You're going to get run over by the thing. Pick a different window. You can usually leave if the low has just passed, but then you're going to have to deal with big seas for the first couple days. Rule number 2, don't route through the high, ever. It's crazy. It's not a good idea. Rule number 3, don't trust the forecast past day 5. This is a dynamic thing. It's not static. You don't just do this once. The forecasts come out bi-daily. Bi-daily? Is that right? Twice a day. So every 9 a.m., every 9 p.m., get up, do your thing, get your weather forecast. It gives you something to do out to sea anyway. And make sure you're watching all of this like a hawk very closely. Rule number 4, always carry your maximum motoring range and jerry cans if you have less than 800 miles of motoring range, okay? Just in case you get caught in here and don't have a water maker, you need to be able to get out and get back up to the wind. Okay, to err is human, and oh buddy, I am human. So when and if you screw this up and you get a little too close to a low, or you get down into the high and run out of wind, what do? Let's talk about the high first. So firstly, back off the throttle. You don't need to go full speed to get out of this. It's not dangerous, it's just boring. So find the RPM that makes the most economical sense, the most efficiency, and use that. 2, look for edges with rising pressure gradients in the forecast. So if there's going to be some higher winds that are coming, aim for that, obviously. And 3, don't panic. If you're making 1 nautical mile a day, it's still 24 miles a day. So sometimes, like I said, my best experiences and my crew's best experiences were in the doldrums. So put out some fishing lines, try to make the most of it. Play some board games. Don't freak out. It's not that bad. You don't always have to be making progress, honestly. Sometimes it's nice to just relax and be disconnected from the world for a while. Okay, conversely, if a low is coming for you, you can't afford to be that laid back. So what do you do if you're about to get hit by a very powerful low and you're just too far north? You're going to alter your course to avoid the worst quadrant, all right? That'll be the southeast quadrant. So as the storm is moving east, it's also turning counterclockwise. And that lower quadrant is going to be the fastest wind and the highest waves, just because of the relative motion of the storm with the way that it's moving. So if you're going to get nailed by the center of this storm, you're actually going to want to go farther north to get out of that quadrant. And you're going to want to time your arrival to hit the edge and not the core. You don't want this thing running you over at full speed, full power. Okay, I'm sorry I have to jump in here again, but this is a very good opportunity to talk to you guys and explain to you the dynamic if you were to get caught in a hurricane. A lot of us are sailing around in the Atlantic or the Pacific, and if you get a cyclone or a hurricane or a typhoon or something that comes after you, what is that dangerous quadrant? Because it's not the same as those lows. Those lows are always traveling in the same direction. So that southeast quadrant is always the dangerous part. But hurricanes, it's the forward right-hand part. Like if you were the hurricane and you were looking forward and going forward, it's this piece, because they are traveling in the same rotational direction, anti-clockwise. And as they're moving forward, their relative direction, and that's wind, makes the waves and the wind the most dangerous in the forward right-hand corner of the storm, okay? I don't know how to explain it any other way. If you're in the southern hemisphere, they're rotating the opposite direction, so that would be the forward left-hand corner, okay? So no matter where they're going, just see where they're going and where they're planning on being, and don't be in that forward right-hand corner. And as far as these lows, obviously it's the southeast corner, all right? Good thing to know. Good thing to know, just in case. You never know. The storms are getting weird now. So they're getting super early and super late, and hopefully that helps somebody. And then, just like all seamanship, when you're dealing with heavy weather, you reef early, you sleep, you eat, you get ready for this storm so the storm doesn't wear you down, and you try to go into it as prepared as possible. Like in my story, I knew it was coming. We were hove to with everything run correctly so it wouldn't chafe 5 hours before the storm hit. And I was hove to, and I thought the storm would get to about 40 knots. It got to about 50 knots, and I had to reef a little bit, but it didn't kill us. So that's what you need to do. You need to just go in there and think, okay, what am I going to do before this comes? Take everything inside. Take all those jerry crans inside. Take things down that are really, really bad. Like if your bimini is kind of ripped and not too nice, take it down. Put it inside. You don't want the windage for one, and you definitely don't want to lose the thing. And always, my rules are stay humble, stay flexible, and watch the trend, not the forecast. All right, so this video series is a chapter in my book. The book is called Be the Captain. It's available at bethecaptainbook.com. Okay, so here's what happened with the book. It's a really cool story. So I finished this book and I put it in the editing phase, and I'm thinking, okay, I'm just going to see if it's got any interest at all. I'm going to put a pre-order page up, and I'm going to sign them. And what I really wanted was for this first order, whoever ordered my book, to get a signed hard copy that was really cool, like embossed and gold leaf lettering, and I could have them numbered, and this is a first edition and it's a special thing. Well, I thought maybe I can sell a couple hundred of these, so I'll limit it to 500. It's sold out in 24 hours, and then now it's up to 1,000 books. So I kind of got scared, and I was like, man, I don't know how long this is going to take. I don't know if this is going to be easy to sign them, or it's going to be like a month of work to send all these out. And I was contacted by one of my patrons, Jonathan Moga. Thank you so much. He's got a business with a high-speed label maker and some people that can help me. So he's helping me out to do this thing. And because of him, now I can sign all of them. So I've got a couple announcements that are super cool. I'm signing and numbering every single first edition of this book. So if you've bought one already thinking that it wasn't coming signed, it is. And I'm also adding an Easter egg inside the book. I thought it would be really fun to have a treasure hunt, and it's going to be a little bit difficult. I'm not going to say anything else about it. You guys are going to have to talk amongst yourselves when you figure it out. It's going to be cool. So every single person that orders a book now gets a first edition signed and numbered book. I'm not limiting them. If it goes to 5,000, that's fine. And this is my image, and this is what I wanted. And I'm making this book as best that I can. It's going to be chocked full of information. This is the table of contents. So we're going to cover, I've broken the book down into 4 sections. It's got 133 subchapters. It is a book that is sprinkled in with sea stories. Okay? So I hope you guys love this. Thank you very much for watching this video. And I'll see you next time. Okay, bye.